2018 Calculus AB number 5. We're doing the average rate of change. So we should know the formula for that. That should be f of b minus f of a over b minus a. So in our case, we're going to get f of pi minus f of 0 over pi minus 0. So plug in pi for x, e to the pi cos pi over, whoopsie, yeah, well, we're still good, minus, plug in 0, e to the 0 cos 0, e to the pi is e to the pi, cos pi would be negative 1, e to the 0 is 1, and cos of, well, that's supposed to be a pi. Cos of pi, oh, that's a 0, my bad. Cos of 0 would be 1. That's all over pi. So our answer is negative e to the pi minus 1 over pi. That is it, average rate of change. So part B, the slope of the line tangent. The slope of the line tangent is the derivative. The derivative gives you the slope of the line tangent. So we need to find the derivative f prime of x, and we need to use the product rule. If you look, we have two functions being multiplied. So the product rule says you take the derivative of the first and you leave the second alone, and then you leave the first alone and take the derivative of the second. Now we're going to plug in 3 pi over 2. Cosine 3 pi over 2. E to the 3 pi over 2, and the opposite of the sine of 3 pi over 2. Okay, pretty nice here. Cosine of 3 over 2 is 0, so that's all gone. And then the sine of 3 pi over 2 is negative 1, so the negative and the negative cancel, so you're just left with e to the 3 pi over 2. And that's it for that. Let's keep going. I like this problem. Not too brain frying. It's pretty straightforward. So we're doing part C. Find the absolute minimum value. So you should know absolute minimums occur at critical points and endpoints. So you need to, it's not a matter of finding relative max or mins. We don't need to do that. We just need to find the critical points and then find the, I'm sorry, my brain's off. Find the y value at the critical points and endpoints. The biggest one's the max, smallest one's the min. Very logical. So we already found f prime of x, so that we did earlier. So critical point, we set that equal to 0. So f prime of x is e to the x cos x, and we had plus e to the x times minus sine of x, so that's e to the x sine x, set that equal to 0. I have a common factor of e to the x, we take that out. You set each one equal to 0. Well, e to the x never equals 0. And then cos x minus sine x equals 0. Well, couple ways to do this. You can just figure in your head, when are the cosine and sine equal? And that's going to be at pi over 4 reference angle in the first quadrant and 4 in the fourth quadrant. So you can get pi over 4 and 5 pi over 4. Or you could do this maneuver. Add sine x to both sides. Divide both sides by cosine x. and you get 1 equals, and sine over cosine's tangent x, and then you ask yourself what angle has a tangent of 1, and that's going to be pi over 4 and 5 pi over 4. So those are your critical values right there. So now, to find the max and min, we need to find the value of f at the endpoint, at the critical points, and the other endpoint. The other endpoint was 2 pi. So we're going to punch that into our original e to the x cos x. Let me put this here so I don't have to keep scrolling up. Well, e to the 0, cosine 0 is 1, so that's e to the 0, which is just 1. Plug in pi over 4, e to the pi over 4, and cosine of pi over 4. Well, the cosine of pi over 4 is 1 over radical 2, so we get that. And then we get e to the 5 pi over 4. And the cosine of 5 pi over 4 is going to be negative, well, I'll go ahead and put this here, negative 1 over radical 2. So that's going to be negative e to the 5 pi over 4 over radical 2. And 2 pi, e to the 2 pi, cosine 2 pi, but the cosine 2 pi is just 1, so it's e to the 2 pi. So we wanted the what? The minimum or the maximum? The absolute minimum. There's only one negative, and they want the absolute minimum value, not where the x coordinate occurs. We are done. If you look, that's the only negative. So we would say the minimum value of f of x on the interval from 0 to 2 pi is negative e to the 5 pi over 4 over radical 2. And that's it for C. And then we have part D. So part D, let g be a differentiable function, and g at pi over 2 is 0. Wow, I am just out of room. I'm going to erase this stuff. I think that's going to be the easiest way to deal with this. And like magic, bam, ooh, not so magic. Ooh, that's ugly. Not pretty magic, okay. So g at pi over 2 is 0. We have the graph of g prime, so that is the derivative of g. And we want to find this limit. I think I know where we're going. I am sensing the L'Hopitals. So let's do this. The limit as x approaches pi over 2 of f of x. We're just going to look at the top only of f of x. Well, that's 0 for a couple of reasons. Whoa, no, liar, liar, pants on fire. I'm looking at g, not f. It's probably going to be 0 also. F of x. So if you look here, e to the x is a continuous function. Cosine x is a continuous function. Therefore, that product's continuous. Therefore, to find the limit, it's the same as the value at the point. So that's going to be e to the pi over 2 cosine pi over 2. But that's just 0 because cosine pi over 2 is 0. So that's 0. We want to take the limit of the bottom, the limit as x approaches pi over 2 of g of x, and we know that's 0. And the reasoning, they tell us g at pi over 2 is 0. And if you could look, g prime exists. The derivative exists. Therefore, the function's continuous. If it functions continuous, then the limit equals the value at the point. That is something you have to know, the definition of continuity. So here we go, I'm going to show you what not to do. This would be very bad because it's a liar, liar, pants on fire statement. I see it all the time. People, oh, that's 0 over 0. That is a false statement. You're saying this equals 0 over 0, and that, by definition, because you're divided by 0, that's undefined. So you're saying this limit's undefined, but it's not. It could be. We are in a L'Hopital situation. L'Hopital, that rule says, if the limit on the top 0 and limit on the bottom 0, or infinity, if they're both infinity, then this limit is the same as the limit of the derivative of the top and derivative of the bottom. I'm going to say, therefore, by L'Hopital's, we get this. It equals the limit as x approaches pi over 2 of f prime of x over g prime of x. Now, f prime of x, we found that. F prime of x is here. We actually found, did we find it at pi over 2? I don't think we did. Let me look. No, we did not. So here's f prime of x. So side work, I'm going to do f prime at pi over 2. And so I'm taking this equation and plugging in pi over 2. So it's e to the pi over 2. I may have found that on the last question. I can't remember. Cosine pi over 2. I erased it also. E to the pi over 2 minus sine pi over 2. Well, that's going to be 0 because cosine of pi over 2 is 0. So sine of pi over 2 is 1. So it's going to be negative e to the pi over 2. That's going to be the top. And g prime at pi over 2, if you just look at our graph here, that's g prime pi over 2. That is 2. So I'm going to plug in a 2 down here. And that is the answer. We are done, finito. That's it. So that's it for that problem. Talk to you guys later.